Today I want to talk to you about air pollution, particularly reconstructing past air quality in the industrial heartland of Britain. That's why I'm talking to you today from the Black Country. Behind me in the picture, if I move a little bit you can see better, um, is part of the central England Canal network. This canal network was used during the Industrial Revolution to move raw materials and finished goods throughout the region. The Black Country is an area in the West Midlands of England. The name comes from the fact that there is about a 30-foot thick coal seam that outcrops at the surface, giving the country its black look. Because of this coal and other raw materials that were locally available, this area became the birthplace of the Industrial Revolution by about 1750. During the Industrial Revolution, this area became one of the most industrialized parts of Britain, with coal mines, coking plants, iron foundries, glass factories, brickworks, steel mills, which together produced a very high level of air pollution. Charles Dickens, in The Old Curiosity Shop, published in 1841, described the air quality as follows. On every side, as far as the eye could see into the heavy distance, tall chimneys, crowding on each other, and presenting that endless repetition of the same dull, ugly form, which is the horror of oppressive dreams, poured out their plague of smoke, obscured the light, and made foul the melancholy air. As a monument to the Industrial Revolution, the first ever iron bridge, constructed in 1779, still stands over the River Severn in the Black Country. But how much air pollution was there? This is a question that I and several of my students have worked on for about 15 years. Even Duluth, prior to about 1970, was an industrial city with no regulation on air quality. And other major U.S. cities were in the same situation. This is New York City. So what is air pollution? It can be dust, smoke, or soot, volatile organic compounds, but generally considered to be, in the Industrial Revolution at least, primarily sulfur dioxide and nitrogen oxides. Sulfur mainly from the burning of coal, and oxides of nitrogen from gasoline and diesel fuel. Particularly early in the industrial era, air pollution was mainly sulfur dioxide from the burning of coal. The basic chemistry of acid rain is fairly simple. Sulfur dioxide reacts with water in the atmosphere to produce sulfuric acid. Nitrogen oxides also react with water in the atmosphere to produce nitric acid. So how do you assess past air quality? My students and I traveled around the West Midlands, primarily by canal boat, navigating the locks and visiting cemeteries, lots of cemeteries. Sometimes we found surprises. This is a femur sticking up out of one of the graves. So why were we in all these cemeteries, you might ask? We were looking for marble gravestones. Marble gravestones are composed of calcium carbonate, limestone, and they're susceptible to rapid weathering, particularly from acid rain. Many of these stones have lead lettering, which provides a marker. As the surface of the stone recedes, you can actually measure the amount of stone that's been weathered away from the top of the lead lettering. By measuring thousands of inscriptions at dozens of cemeteries throughout the West Midlands of the UK, we were able to determine the rates of acid deposition over time. As an example, this gravestone, let's picture this gravestone on the left here, has two inscriptions. The James William Whitehouse died in 1926 at the age of 37, but his wife did not die until 1985. And so the fact that the stone has two inscriptions dating to different times, and obviously the stone was repolished when Rachel passed away, it gives us, we can calculate a rate of acid deposition. By plotting up these data from many stones in particular cemeteries, we can actually come up with a rate of acid deposition over time. And that rate of acid deposition is, of course, related to air quality. And the air quality in urban areas, such as the central part of the city of Birmingham, is very different than the rate of acid deposition in rural areas. And we can actually determine the spatial and temporal rate of acid deposition, and therefore the spatial and temporal changes in air quality. Using some simple math, we can then convert these weathering rates to atmospheric concentrations of gases, and then plot up over the time interval for which our inscriptions cover, in this case from 1890 to 2010, we're able to actually plot up air quality as a function of space and time. Notice in 1890, the beginnings in the West Midlands, the beginnings of fairly poor air quality. By 1910 and 1920, getting worse. Throughout the 30s, 40s, 50s, 60s, and on into the 1970s, air quality was at its worst in this region. By about 1980, environmental regulations on air quality had dramatically improved the quality of the air in this region. So that's your 5-minute bit on air quality in industrial Britain during the Industrial Revolution.